Welcome. We're about to jump into a topic that completely flips the script on how programs run in Java. I'm talking about multithreading. Seriously, this changes everything you think you know about performance and making your apps feel, well, alive. You've definitely seen this, right? One app is downloading something, you're typing away, maybe music's playing in the background, and it's all perfectly smooth. Then you open another app, click one button, and the whole thing just freezes. What is the magic that makes that difference? Well, it all comes down to concurrency. So, to get how we solve that freezing problem, we first got to look at how things start out. By default, every single Java program you write runs on what's called the main thread. It's basically a single path that your code follows from the very beginning to the very end. And this one-lane road analogy, it's perfect, because think about it. If one car, one single task, is slow, what happens? You get a traffic jam. Everything behind it is stuck. Nothing else can happen until that one slow task is finished. For any real-world app, that's a massive, massive bottleneck. Okay, so how do we bust up that traffic jam? We don't try to make the one car go faster. Nope, we build more lanes. And in the world of programming, building more lanes means introducing more threads. We're turning our little one-lane country road into a multi-lane superhighway. So here's the key definition. A thread is the absolute smallest piece of a program that can be run. And multithreading is what lets our app run a whole bunch of these pieces concurrently, making it seem like they're all happening at the exact same time. That's how we get that super smooth, responsive feel we're all after. All right, so we're sold, we need more threads, but how do we actually make them? In Java, you're immediately faced with a big choice. And the path you pick here really matters for how your code is designed and how flexible it's going to be down the road. And here they are, the two main ways to get it done. You can either extend the thread class itself, or you can implement something called the Runnable interface. They might look kind of similar at first glance, but trust me, the difference between them is a really big deal. Let's break this down because it's super important. If you extend the thread class, that's it. You've used up your one chance to inherit from anything else in Java. That's a huge limitation. But if you implement Runnable, your class can still extend some other class. Even better, Runnable separates the task, the what you want to do, from the thread, which is the how you're going to do it. That's just cleaner design, and it makes your code work with all the modern, powerful tools. So yeah, the verdict is pretty clear. Extending thread might feel a tiny bit simpler if you're just messing around, but implementing Runnable is the way the pros do it. It gives you way better design, you can share resources more easily, and it just sets you up for success when you build bigger, more serious applications. Okay, so we've built our awesome multi-lane highway. But what happens if you suddenly have thousands of cars, or threads, all wanting to do really short trips? It would be total chaos. Manually creating a new thread for every tiny task and then destroying it, well, that's just incredibly inefficient. It's a management nightmare. And this right here is the next big hurdle. Every time you ask for a new thread, you're basically asking the operating system for a pretty expensive resource. If you do that thousands of times for little tiny jobs, you're just burning through time and memory for no good reason. There has to be a smarter way to handle this, right? And of course, there is. It's called the Executor Framework. And this worker pool analogy is spot on. Instead of going through the whole process of hiring and then firing a new worker for every single tiny job, why not just keep a pool of skilled, ready-to-go workers on standby? When a job comes in, you just hand it to one of them. It is so much more efficient. This shows you exactly how it works. You've got all your tasks lining up in a queue. The Executor Framework has its pool of worker threads just waiting. It grabs the task from the queue, hands it to an idle thread, and that thread gets to work. But here's the magic. When the task is done, the thread doesn't just vanish. Nope, it goes right back into the pool, ready for the next task. Reusing threads like this is what makes the whole system so incredibly powerful. So we went from one lane to a managed highway. But what if we could make that highway almost infinitely wide? And what if each lane was so cheap it was basically free? Well, that's not science fiction. That's the promise of the latest and greatest evolution in Java, virtual threads. And here's the night and day difference. The threads we've been talking about up till now, those are called platform threads. Each one is a heavy, expensive thing managed by the operating system. You can't have too many of them. But virtual threads, they are a total game changer. They're super lightweight little objects managed inside Java itself, the JVM, and you can create millions of them without breaking a sweat. So how does this magic actually work? Well, a virtual thread is really just a simple Java object. The JVM has a small, hidden pool of those old-school platform threads. When a virtual thread needs to run, the JVM just mounts it onto a platform thread. But if that virtual thread has to wait for something, like a network call, the JVM instantly unmounts it and lets another virtual thread use that precious platform thread. It's efficiency on a whole other level.
And this quote just nails it. The whole idea of a thread being an expensive thing we have to carefully manage, that's just gone. Virtual threads are so cheap and fast to create, it completely changes the way we can even think about writing our code.
Okay, let's just pause for a second and look back at the journey we just took. We've gone from the simplest possible program all the way to the absolute cutting edge of how software can run. We started with that single lane road, that one main thread, and saw how it was a huge bottleneck. So we built a multi-lane highway with more threads and learned that using Runnable is the best way to do it. Then we brought in a traffic manager, the Executor Framework, to keep that highway running smoothly. And finally, with virtual threads, we basically made that highway infinite. And that leaves us with this final thought. For years and years, developers had to be so careful about creating threads because they were expensive. But now they're basically free. This opens the door for a whole new class of applications, especially those that spend most of their time just waiting for data from a network or a database. So the real question isn't just about how we write our code anymore. It's about what kind of incredibly responsive, massively scalable software is now possible. What can we build now that we couldn't build before?